Welcome. In this video, we will be creating toolpaths for the CNC router using RhinoCAM. We will be using a 3ds file that we exported from Sketchup to make a mesh upon which we will create our toolpaths. We're going to start in Rhino by importing the 3ds file that we created with Sketchup. So click open, and you can see it's huge. It doesn't even fit in my viewport, so I'm going to type ZE, and I'm going to maximize the top viewport so that I can maneuver a little more easily. I'm going to make a rectangle, and this rectangle is going to serve as a guide for when I scale my meshes. And I'm going to select everything, and I'm going to scale. I'll choose one corner of my rectangle as the origin, and I will snap to an adjacent corner on the rectangle. And I'm going to scale this down so that my rectangle is 36 inches because that's the size I want it to be, my finished product. I'm going to zoom extents again, and here it is. So before we go any further, let's double check. Click on properties, and we'll click on units, and we're going to double check and make sure that we're in inches and not millimeters. We need to be in inches in order to use the CNC. Now we're going to move all of this to 0. So type in 0, and here we are. So you can see that the corner of my rectangle is at x0, y0, z0. So I'm going to drape over this, and my spacing is at 5. Start down here in this corner, go up to the opposite corner, and here's my drape. I found that drapes look better than the meshes that come in from SketchUp. I'm going to move this draped mesh to layer 1. You can see here it's red. It'll help keep things clean, and I'll be able to differentiate between what other things that are going on here. I'll move that rectangle that I drew to layer 2. That's purple. And I'm going to shut off the mesh that I got from SketchUp. So here we go. We'll open up perspective, and you can tell here. You can see that I have my new mesh that I got from draping, and it's actually less faceted than the Google SketchUp mesh. There are still some facets you can see, but it's a lot better. Okay, so I'm going to take this curve, and I'm going to extrude it, and I'm going to make a box. And this box is going to be sort of taller than my highest Z here. So I'll do 2 inches. And now I'm going to move this giant box down a little bit so that all of my Z-axis is encompassed within it. And the purpose of this box is to serve as a cutting tool, because we're going to trim this. If you remember here, our mesh is actually bigger than 36, so I'm going to trim everything outside of this box. There we go. Click on layer 1, and we'll hide layer 2 so the box is gone. There we go. This is my model, and it's at 1:1 on the CNC right now. So I'm going to open up the machine operations browser and the cutting tools browser in RhinoCAM. And if you look here underneath the tools, there's nothing. So I'm going to load the tool library, and our tool library is saved as a VKB file, not CSV. So we'll open that up, and here we go. We have 35 tools. We'll go ahead and close our cutting tools browser, and our next step is to set up our stock. So we'll double click stock, and we'll go down and copy model bounding box, and this is going to make a stock box that is equal to the extents of our model. But since I know that the stock that I have glued up already is 2 inches thick, I'm going to change the H to 2. Click OK, And our next step is to locate the WCS. And this is basically 0 for our part so that the CNC knows where to go. We'll set it to the highest Z and southwest corner. And click OK. And now we will align part and stock. And this will make sure that our part is at the top of the stock and in the middle. Click OK. I'll maximize the perspective viewport. And you can see here how our part is completely encompassed in the stock. That's good, that's what we want. Our next step is to create a toolpath, so we'll click the Create tab, and we're going to make a 3-axis toolpath. We're going to do horizontal roughing, so we'll click that, and we're going to select our tool. Our tool is going to be a 3/4 inch upcut end mill. Here it is. We'll click on Feeds and Speeds. We'll load those from Tool, and next we'll click on Cut Parameters. For the most part, these settings are okay, but we're just going to change a few things. We're going to change the cut direction so that it's conventional, and then we're going to go down and change the step over control so that it's at 45%. This will make our cut times faster. The rest of these tabs are fine. You don't have to change the default settings. I tend to change the cut arc fitting and smooth cut transitions under advanced, but you don't need to. So click Generate, and there we go. Let's make sure the toolpaths are visible here. So all these blue lines represent where the center of the end mill is going to go. So we'll click on Simulate, go down and select our toolpath and hit Simulate. This shows us exactly what the CNC is going to do and what our stock is going to look like. And we'll just double check this to make sure that we're not going outside of our box too far, or we're not, cutting someplace we don't intend to. That looks good. So let's click Create, and we're going to make another 3-axis toolpath called Parallel Finishing. We'll go up and select a tool, and for this we're going to use a 1/2 inch ball nose, the 0.5B. We'll click on Feeds and Speeds. We'll load those from Tool. Click on Cut Parameters, and here we're going to leave everything except for the cut control. Actually, we'll put the cut control back at mixed. It'll make it cut faster. We'll change our step over to 30%, which will make for a faster toolpath. And we'll click Generate. And here we go. You can see all the blue lines again. This is where the center of our cutter is going to go. There are a lot of lines, so generally that means that this is going to take quite a while to run. Again, we'll simulate this toolpath. This toolpath actually took about 8 minutes or so to simulate, which is quite a long time for a toolpath simulation. So if I were to estimate the runtime on the CNC, I'd say maybe an hour and a half or 2 hours. It's really hard to tell. It's more of an art than a science, determining how long the runtime is going to be. Let's go ahead and take a look at the quality of our surface finish. You can see it's not too faceted, but it is fairly scalloped. And if you didn't want so much scalloping on your part, you could either use a smaller diameter ball nose end mill, or you could decrease your step over, say to 20% maybe. But then again, it's going to lead to a longer runtime by decreasing your step over. Let's go ahead and save this, and now your file is ready to be reviewed by